Now we're looking at the demand for labor in a perfectly competitive market. So we want to think about how the amount of labor hired is going to affect the benefit from that work, another worker for the firm, so that marginal revenue product of labor, as well as the cost. So one thing that is important from our context, right, the fact that it's a perfectly competitive market is the price of the labor is not going to change, right? Wage is going to be constant, and we're going to show that, whoops, sorry about that. We're going to show that with an upward sloping, or sorry, not upward sloping, a horizontal price line. So that wage is constant. Okay. But marginal revenue product is going to be downward sloping because as the number of workers hired increases, we're going to see the productivity of each of those additional workers fall, right? The labor itself is going to demonstrate diminishing marginal returns. So because marginal productivity decreases with each unit of labor hired, and that's going to give us a downward sloping demand curve. And again, because we're in that perfectly competitive context, the price that the firm can sell its goods at will be constant as well. So that marginal productivity is the only thing causing that demand for firms' labor to be negatively sloped. An important assumption we're going to make, and this is coming from chapter 6, as more labor is used, output increases, right? So that's that same one we saw in chapter 6, where as the number of inputs increases, output increases. So even though we're seeing diminishing marginal productivity for labor, um, as more labor is hired, output is going to increase, but we're going to see that output increase less, and so firms are going to be less willing to pay for each additional worker, right? Because that worker is producing less that they can sell, right? In other words, that marginal revenue product falls. An increase in output, however, is going to affect the price of the firm's good. So as output increases, right, if we look at a supply and demand graph, um, consumers are less willing to pay for that good as the price, excuse me, as there's more available, right? And so that price is going to tend to fall. And so as marginal revenue falls, marginal revenue product also falls. So now when we consider the connection between the amount of labor employed and the amount of output, we see marginal revenue also providing that downward pull on marginal revenue product, right? So that's again going to give us a negatively sloped marginal revenue product curve. All right. So how much labor will firms ultimately hire? It's when the benefits to hiring those workers equal their costs. So essentially at the point where marginal revenue product equals the wage. And that gives us that optimal amount of labor. If marginal revenue product exceeds the wage, right, if we're at this L star sub 1 point, right, we can see that those workers, the firm hires at a wage above the market wage. So that means that what the firm's going to do is increase the amount of workers they hire because they're sort of leaving these games of unrealized production on the table. And they're going to increase until the last worker they hire gives them a benefit equal to the cost of that worker. If instead we're at amount of workers, amount of labor L star 2, we see that the firm values those additional units below the market wage, right? Below the cost for those workers. And so what the firm's going to do is actually reduce the amount of labor they hire until that last worker that remains hired provides the firm a benefit exactly equal to what it costs the firm to have them on the payroll. All right. Looking at our marginal revenue product curve, We can see that it is a demand curve, right? I've been referring to it as firm's demand for labor, and it's going to have the same type of properties that we've seen with other demand curves over the course of this class. So it'll have a choke wage, right, where it intersects that wage axis, excuse me. And that is the wage at which a firm is not going to want to hire any labor. It's going to have a quantity intercept, and that is the amount of labor that the firm would hire if the wage were zero. And it's going to it's going to be downward sloping. So as the wage decreases, right, from W1 to W, we see the amount of labor hired increase. And if the wage instead were to go from W2 to W, right, we see that amount of labor hired decrease. Okay, so it's going to be downward sloping. It'll have a choke wage representing, again, the amount, the price at which the firm will hire no labor, and then a quantity intercept, which represents the amount of labor the firm would hire at a price of zero. This gives us a really useful optimal condition where firms will hire the amount of workers that cause the wage and marginal revenue product to be equal. Okay. So since we know marginal revenue product is equal to the marginal product times the marginal revenue, and we know that marginal revenue product equals the wage, we can just substitute the wage for marginal product. And this gives us a relationship between the benefits to the firm and the costs. And we can actually rearrange this equation where we'll divide both sides by the firm's marginal productivity. And it gives us a form of these values where we can really see that cost to benefit relationship for the firm, right? And they're going to be willing to pay the amount that equalizes those two in equilibrium, right? That optimal point is where the cost of the wage, um, which is the cost of the worker, is going to exactly equal the benefit from that worker, which is their productivity. Okay. So this first point on the slide here is just what we said. At the equilibrium point, at that optimal point, the firm will hire workers such that the marginal revenue equals the wage divided by the marginal product of labor, right? Another way of saying this is the firm will hire the amount of labor such that the benefits exactly equal the costs. And so we also get what we saw in our chapters on firm theory, the equilibrium condition of firms producing where marginal revenue equals marginal costs, right? And so this optimal, this profit maximizing condition tells us that the firm is also hiring the optimal amount of labor. Okay. Because we have this connection between firms' output and the amount of labor they hire, we get very clearly this fact that labor is a derived demand. What this means is that firms don't actually demand labor, they demand what labor can produce. They want to hire people to make their product so that they can sell it, right? They ultimately demand that product, and by hiring labor, that lets them get that product. So the demand for labor arises out of the demand for another good, another product. Okay, in this case, the demand for labor arises out of the demand for the firm's output. All right, let's look at another example. So let's say that a firm has hired their optimal amount of labor. The marginal productivity of labor of the last worker hired is equal to 10 units, and the wage is equal to 120. We want to know what the marginal revenue must be from the last worker hired. So what marginal revenue does the firm earn from that final worker that they employed? And we just discussed how in equilibrium, right at that optimal point, marginal revenue is going to equal the wage over the marginal product of labor. So let's go ahead and substitute those values. So we'll have 120 over 10, and that's going to give us 12. So the answer is B. So with that, we've established sort of the baselines of how the demand for labor is going to operate in the perfectly competitive market and what the optimal conditions are. Now that we know those, we can look at how changes to our market will impact that optimal point. All right. So let's start with thinking about what's ultimately going to cause the labor demand curve to shift. So because labor demand is given by that marginal revenue product, which is the multiplication of the marginal product of labor times marginal revenue, anything that changes either of these factors is going to result in a shift of that curve. So let's look first at changes to marginal product. So marginal product, of course, depends on the production function of the firm and the amount of capital employed, right? Remember that we're in the short run, so capital will be fixed, and that most often we see production functions that are in that Cobb-Douglas form. So capital to some exponent times labor to some exponent, all right? And then what is modifying this as well is this constant A, which we use to refer to total factor productivity, which is technological change. So if for some reason there was a technology shock, right, this value of A gets bigger, maybe it goes from 2 to 4, what we're going to see is that the labor itself is going to be more productive, right? So if we were to look at a production function where we have quantity equal to 2 times capital to the alpha times labor to the 1 minus alpha, if we find the marginal product here, all right, we take the partial derivative of output with respect to labor. That's going to get us 1 minus alpha times 2 times k to the alpha times L to the negative alpha. All right. So you can see if we compare this format for marginal product of labor to that when this 2 is instead of 4. All right, let's look. So we have quantity equal to 4 times k to the alpha times L to the 1 minus alpha. Marginal product of labor is going to, again, be that partial derivative of output with respect to labor. And we're going to get 1 minus alpha times 4 times k to the alpha times L to the negative alpha. So you can see that everything is the same except for that constant here, 2 and 4, modifying our equation, right? And 2, or excuse me, 4 is twice 2. And so that means that firms, or excuse me, laborers with this 4 factor for total factor productivity are going to be more productive. All right, so if we have that increase in total factor productivity, we're going to see a shift out of the firm's marginal revenue product curve. And that's going to mean that at the given wage, the amount of labor hired goes up. Okay. We are going to see changes in marginal revenue also affect this curve. And the reason for that, again, is because labor is a drive demand. So as the price of the firm's good changes, that's going to impact their marginal revenue, and that's going to impact how much labor they want to employ. So let's say that for some reason, the demand for the firm's product falls, meaning that their price falls. That gives us a fall in marginal revenue. So marginal revenue falls. Um, and fewer people are demanding their product, and so firms are going to hire fewer workers, right? In turn, firms are going to demand fewer workers, right? So if we show graphically that fall in the marginal revenue, right, we're going to shift our marginal revenue product curve back into the left. That's going to give us a reduction in the quantity of labor hired. Okay. All right. A change in the market wage can also cause a shift in the firm's demand for labor, but this is going to be due to the impact on the firm's marginal revenue. So let's walk through this together. So if the market wage goes from being wage 1 to wage 2, that's going to mean that now the firm is paying less for its workers. So its costs of production across the industry have fallen. Graphically, if we were to show the supply and demand curve for the firm's good, right, whatever they produce, that would be represented with a shift out into the right of the firm's supply curve, right, of that market supply curve. And so we're going to see that their price that they get for their product falls. which means that their marginal revenue falls. And so we're going to see a shift in their marginal revenue product curve back to the left, down and to the left. And as a result, right, even though the wage has fallen because they have that lower demand, now the amount of um, labor they hire is less than it would be if they had the same level of demand at that lower price, but it's more than they were hiring at the higher wage. Okay, so we see with the fall in the price what we expect an increase in the quantity demanded of labor, but it's less than it would have been otherwise, right? It's muted. All right, and then this slide just walks through exactly what we talked about just a moment ago. Okay. Here, just to touch briefly on the supply of labor in a competitive market. We're not going to get into this um, in much detail because this is what you'll cover in the other intermediate class where you're working with the utility model. Um, but because workers are the ones who are the supply curve in a labor market, they're going to have all of the assumptions from the perfectly competitive market that we used from chapter 8 applied to them. All right. And what we're going to see is that the trade-off they face is essentially what we call the labor-leisure trade-off. They choose to work so that they can engage in leisure. They don't like work, right? And so they're going to work only as much as they have to. And that willingness to work is going to depend on how much they're paid, right? Is it worth it for them to give up their leisure time? It's going to depend on their age, their family situation, their health, and so on, right? So factoring all these in, we're going to see how each person decides how much to work versus how much to take in leisure time. All right. And that's as far as we're going to go with that labor leisure theory. We're going to go ahead and stop here and come back to look at the labor market as a whole.